All right, Algebra 1B students. Welcome to part 1 of lesson 8.5. We are going to start talking about a huge overarching topic in algebra, factoring a quadratic equation. All right? But we're going to begin, as we have the past many videos, the past many lessons, by using FOIL to simplify this expression, this multiplication of two binomial expressions. All right? It says x plus 3 times x plus 7, both of those in parentheses. I will start with the first term in each, that's x and x, that's x squared. Outside, x and 7, inside x and 3, gives me a total of 10x. And my last is 3 and 7, which gives me a plus 21. So there is what I get when I FOIL those two binomials together. Now, the whole point of this video is doing exactly that, but going the other direction. We're going to go now from a quadratic equation, and we're going to try to factor it into two binomials multiplied together, each in parentheses. Okay. If you would turn with me, please, to page 512. That is where we will start. Page 512 in your textbooks. And your book begins by saying this. We can write some trinomials, keyword here being some. We cannot do this all the time, but sometimes. We can write some trinomials of the form x squared plus bx plus c as the product of two binomials. Just so we're clear, b and c here are just both numbers, some number. They could be any number, really. Well, I shouldn't say they could be any number. Some numbers will work and some numbers will not. To understand how, let's consider the warm-up problem that we just did. Okay, x plus 3 times x plus 7. That was our warm-up problem. And yes, we ended up over here with x squared plus 10x plus 21. The question is, how did we get there? Well, in order to find the middle term on the x's, that was our outside and our inside. X times 7 and x times 3. But x times 7 and x times 3 really is, when we add those up, it's 3 plus 7 times x, or 7 plus 3 times x. That gave us our 10. Right? So we took, essentially, these two numbers here, the 3 and the 7, and we added them together to get 10. Yes? In the same way, when we did the last part of our FOIL, that was 3 times 7. 3 times 7 gave us the end of our equation, which is 21. 3 times 7 is 21. So again, what we did is we took 3 and 7, and we multiplied them to get 21. So our two numbers added up to get 10, and they multiplied to get 21. So here is something to add to your notes. Right here. In order to go backwards and factor a quadratic of this form, x squared plus bx plus c, you have to find two numbers that satisfy the following condition. They have to multiply to get c, and they have to add up to get b. Right, so whatever number you see right here, the two numbers need to add up to get that. And whatever number you see right here, they need to multiply to get that one. Okay? Let's look at a couple examples now. And then I'll have you do a couple yourself as well. In this example, problem 1, they want us to find the factored form of x squared plus 8x plus 15. In order to do that, we need to find two numbers that add up, add to get 8, and multiply to get 15. So the way your book does this, which I think is a pretty handy way of doing it, is we're just going to list out the factors of 15 and then see which ones of them add up to be 8. So factors of 15 meaning two numbers that would indeed multiply to get 15. What two numbers could we multiply to get 15? Well, we could try 1 and 15. That's what they did first, here. But 1 plus 15 is not 8, that's 16. So that one doesn't really work, does it? What other two numbers could I multiply to get 15? Well, I could try 3 and 5. 3 plus 5 is indeed 8. That's good. Yay. We like that one. So my two numbers here are 3 and 5. So if I'm going to factor this equation, I'm going to factor it into x plus 3 and x plus 5 with the multiply sign in between. All right? X plus 3 times x plus 5. And we can fairly easily check our work by just doing a quick FOIL method. Obviously, x times x is going to give us x squared. X times 5 is 5x. X times 3 is 3x. Together, that's 8x. And 3 times 5 is 15. So we get exactly back up to here. That's very good news for us. So, x plus 3 times x plus 5 is our factored form. All right? Now, I would like you to try this equation. What is the factored form of r squared plus 11r plus 24? Pause the video, try that yourself to find two numbers that will multiply to be 24 and add up to be 11, and then write your factored form. Okay? Pause the video, take a look at that, list your factors, list what they add up to, find your numbers that work, and then come back and I will show you the correct answer. Okay, factors of 24 that I could list. 1 and 24, they add up to 25. That doesn't work. I could do 2 and 12. They add up to be 14. That also doesn't work. I could do 3 and 8. Oh, they add up to 11. Yay, there it is, 3 and 8. So my factored form is x plus 3 times x plus 8. X plus 3 times x plus 8. That is the factored form. So, all right, now let us go on to factoring when a trinomial has a negative coefficient of x. Coefficient, remember, means the number in front of the x. So the number in front of the x, or our b number here, is going to be negative. Going to be less than 0. Okay. Let's look at the example x squared minus 11x plus 24. X squared minus 11x plus 24. I still want to be listing pairs of factors of 24, but now, instead of listing pairs like 1 and 24, 2 and 12, 3 and 8, I'm going to list negative factors. Why do I want to list negative factors? Because I want the two numbers I list to add to be a negative number, but multiply to be a positive number. So if I want two numbers to add to be negative and multiply to be positive to be positive, both have to be negative. Because if I want them to multiply to be positive, they have to have the same sign. Negative times negative will get me back to a positive. Now, listing the factors is very similar to the last example you just did. Factors of 24, but both of them being negative. Negative 1 and 24, negative 24. They add up to be negative 25. That's no good. Negative 2 and negative 12. They add up to be negative 14. That's no good. Negative 3 and negative 8. They add up to be negative 11. That's exactly what I am looking for. Check mark. There's my winner. So my two factors now, I'm going to take this number here, and I'm going to take this number here and attach those to my x. Right. So I'm going to do parentheses x plus negative 3 and x plus negative 8. Now, adding a negative, hopefully we know, is very much like subtracting. So instead of doing this, I will rewrite this as x minus 3 and x minus 8. Back to form, and I am done. Okay. Now I'd like you to take a look at the got it number 2 questions, which are right near the middle of page 513. This is page 513. Letter A, I would like you to factor this equation here. And letter B, explain to me why you can or cannot factor that next equation. Pause the video, take a look at those two, come back and I will show you the correct answer. Okay, letter A, our factored form there should be x minus 2 and x minus 4. Now, letter B. Can you factor that equation? The answer is no. The question is, why not? Well, because I'm looking for two numbers that would multiply to be 2 and add up to be a negative 1. Remember that there's a negative 1 in front there. So if I list out the possibilities for multiplying to be 2, I can either do 2 times 1 or negative 2 times negative 1. But 2 plus 1, if I were to add those up, that's 3. That's no good. And if I were to do negative 2 plus negative 1, that equals negative 3. So neither of these equal negative 1. So I don't want that one, and I don't want that one. So I will say there are no factors of 2 that add to negative 1. It's impossible. Can't do it. All right? And you will see that a lot of times in life, and especially later on in algebra class. A lot of times we can't always factor because none of our factors quite work out the way we need them to. Okay. All right, let's turn to the next page, please, to page 514 together. And we will look at polynomials that have more than one variable in them. Your book there in the middle of page 514 says this. You can also factor some trinomials that have more than one variable. Consider the product p plus 9q times p plus 7q. If I were to do a FOIL method here, my first would be p squared. My outside is 7 times q times p, or 7pq. My inside is 9 times q times p, or 9pqs. And my last is 9qs times 7qs, which we know is 63q squared. 63 and q times q is q squared. So I should be able to go backwards from here back to my factored form, right here, in the same way that I've been doing on the previous slide. So a trinomial with two variables may be factorable if the first term includes the square of one variable, the middle term includes both variables, and the last term includes the square of the other variable. That is something I would expect to see in your notes when we get to class tomorrow. Okay? Here's a quick example for you. We will work this one out together and then we will be finished. What is the factored form of p squared plus 16p cubed plus 55q squared? What I need to do here, the same process that I've been doing on the last page, is look at this number here. This number here, my 55q squared, and this number here, my 16p cubes. Okay. I'm still just going to look at the numbers in front of them, not actually at the q's and p's. I need two numbers to add to 16 and multiply to 55. So I'll start listing out the factors of 55 that I know, see if I can get any of them to add up to 16. The first factors I know would be 1 and 55. They add up to 56. That's not what I wanted. Let's see. I could also put 5 into 55. I think that goes in 11 times. 5 and 11. Oh, yep. They add up to 16. That's exactly what I want. Put a big check mark. There's my two factors. So the factored form here now is going to have something to do with a 5 and an 11. The only thing I need to remember is that somehow I need p and q both involved here. Okay? So my first two terms can still just be p, because p times p will give me my p squared, which is up there. But now my last ones both need to somehow involve a q, so that I can get a q squared when I multiply those. So instead of just adding 5 and 11, I'm going to add 5q and 11q. Now if I did a quick check of my work, p times p is p squared, p times 11q is 11pq's, p times 5q is 5pq's, add those up and you get 16, and then 5q times 11q gives me 55q squared. Good. That is my factor form with p's and q's both involved. If you have questions about anything I've just done, please make a note to ask me in class tomorrow. Otherwise, you are ready for your practice problem set and your new life involving factoring a quadratic equation. Have a great night. That's all I have for you right now.